In their simplest form, a bearing is an angle between 2 points, but rather than just being a normal angle, it's going to be measured from north in a clockwise direction. These are the key points that you need to know. So first of all, a bearing always has to have 3 digits. So you could have 343 degrees, that would be fine. You couldn't, however, have 42 degrees. To get your third digit, you'd need to put a 0 in front of it, and that would then be an allowed bearing. You also won't have decimals for bearings. We always measure from north, so any time you've got a point that you're measuring from, you'll draw on a north line vertically upwards. From here, you'll measure round clockwise, so it's in this direction, and as you can see from the ones I've put above, you must put degrees on your measurements. Okay, so first up we're going to look at how you'd measure a bearing. So you might have a diagram and the question could ask you to measure the bearing. So in black here I've got my example of measuring the bearing from A to C. So it says I'm going from A, so I'm going to go to my point A. This is where I'm starting from, and I always start my measurement from the north line here. So I'd label it with north, start at that line and go clockwise until I reach the line which is going towards C. So I'd measure this bearing here and it looks as if it's about 100 degrees. On the other hand, we might be asked to measure the bearing from B to C. So again, here's our from B, which means that we're going to be starting at this point here. We're again going to start from our north line, measuring clockwise. So if that's north, we're starting here and going all the way around clockwise until we reach that line there. This time we look as if we're somewhere around 240 degrees. Ideally, get yourself a 360 degree protractor because then you'll never have any trouble measuring. Sometimes you'll have a bearing question which looks like this diagram, where they've given you a bearing. It may well say not to scale underneath, so you can't do any measurements to answer the question, but they might say to find the bearing from Q to P. Okay, so if it's asked you to find the bearing from Q to P, we're going to start over here at Q, again measuring from north, going clockwise. So that is the angle that we want to measure, but all we know is that this angle here is 95. Therefore, to answer this question, we're going to need to use the fact that we know that the two north lines have to be parallel to each other. So we might find it helpful to extend this line a little bit further. Now, looking at this angle here and this one here, and the fact that these are parallel, we know that this angle and this angle are corresponding, and therefore corresponding angles are the same size. So that part there is going to be 95 degrees. Following round clockwise from that blue line now, we're going to go back until we reach the line going to P. Now that's a straight line, so it's got to be 180 degrees. Therefore, the total bearing is going to be 180 plus 95, because we've got to go through the 95 and then a bit further, the 180 further, to get to our line. Final answer there would be 275 degrees. Okay, so here we've got an alternative format of the question. They might have given it to you in words. So it might say the bearing from Q to P is 300 degrees. Find the bearing Q from P. So we might want to add that information onto our diagram first of all. We know that the bearing from Q to P is 300 degrees. So starting at Q, this bearing here is 300 degrees. We're going to do it in the similar way to last time, using our corresponding angle facts. So if we extend that line there, we again know that this is a straight line, so that's got to be 180, therefore leaving the section that we haven't yet labelled, which is up here, to be 120 degrees. I found that just by doing the 300 of the total bearing minus the 180 on the line to give me what's left over. Corresponding angles, we know that this angle and this angle are equal, so therefore that's got to be 120 degrees, and that's actually already given us our clockwise measurement from P to Q, so our final answer is 120 degrees. You might have noticed from these two examples that the bearing in one direction is always 180 degrees different to the one in the others. So if it's 120 degrees out, you'd add on 300 to get the degrees back, or if it was 300 degrees on the way out, you'd have to subtract it. Essentially, to know if you're adding or subtracting, if it's less than 180, you'll add. If it's more than 180, you'll subtract, because we don't want a bearing that's less than 0 or that's bigger than 360. The last stage of likely problem is for it to have 3 points, and they might ask you a variety of different bearings. So looking at what we've got so far, we know this is 100 and we know that this is 200. It might help us out straight away this to add on any unknown bearings which aren't written on. So these have got to add up to 360, so that's got to be 160 degrees. We might start by extending a few lines, so I could extend this line down here, and therefore again I've got a straight line. That's got to be 80 degrees. Now if we look here, we've got a parallel line connected by our transversal. So parallel and parallel, transversal line. So this angle is alternate to that one there. So that angle has got to be 80 degrees as well. We can do a similar thing on the other side. If we extend that line going directly south, then we've got parallel line here, and this angle is alternate with that one. So that also has to be 160 degrees. Now that we've got them, we can fill in some other missing angles. We've got a straight line here, so that angle there has to be 20 degrees. Another straight line, so 80 plus something is 180, so this one's got to be 100 degrees. We also could have found that by the fact that this angle is alternate with that one there. Okay, so that's pretty much everything written on that we could need. So first of all, we've got to find the bearing of M from L. So we're starting at L, and we've got to go round clockwise until we get to M. We can read that one off straight away. It's 200 degrees. Okay, now we've got to do L from M. It's a reverse bearing, and as it's bigger than 180, as we said before, we can just take off 180 from 200, giving us 20 degrees. Think about it. Is that got a 3 digits yet? No, it hasn't, so we're going to add the 0 in front. Okay, next up we're going K from M. So we're starting at M, and we've got to go clockwise all the way until we get to the line that's heading towards K. So we're going through a lot of degrees this time. We've got 20 degrees, then 160, then 100. So we've got 180 so far to here, then another 100, so in total we've got 280 degrees. Then we're going to go to M from K. We could look at our diagram, and we're going from K round to M, read it off as 100. The other way we could do it is to look at our 280 and take off 180. Either way, that gives us 100 degrees. Make sure you've understood all the examples that we've gone through in this video, and if you've got any questions, post them in the comments on the Edmodo group and I'll answer them so that everybody can see.